Hello and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. Last time we met, we spent some time on the CDC website, got more familiar with the BRFSS variables, and learned how to call columns from our data file into the R console. Today, I'm going to start by teaching you some quick tricks. We'll subset our data file, and then we will make a hypothesis. So let's get started right away in R. I will set my CRAN mirror to the cloud. I'll go ahead and set my directory now as well because we'll be calling our data file from it later. Since I'm here, I will load our libraries that we've been working with, Rio and the tidyverse. Alright, and at the end of the last tutorial, we were talking about as.numeric, as.factor, and I said you may be able to set the class of your variable to an integer by using as.integer. And yes, you can. Anytime you want to check on whether something is a function, or if you know something is a function and you want to check the arguments that go into that function and look up the documentation, you can do that by just typing question mark and then the name of the function directly into the R console. So question mark as.integer, press enter, and it will take you to the internet. So here we have the documentation. This is the function we're looking for. There are a couple of variations. Here are the arguments that go into it, some more information, and if you scroll down to the bottom, there are examples. So these are helpful as well, especially for more complicated functions. Alright, so that is your trick of the day. Now, our data file is large. I'm going to go ahead and import it while we head over to the CDC website. So llcp 2017.csv quote header equals true. So we'll let that run. Yeah, it looks like it's running. Let's go to the CDC website. CDC BRFSS 2017. First result. Okay, today we're going to be in two data files. The first is Codebook. The second actually is not a data file. It's just a page. So BRFSS modules used by state. Because if you remember, I told you that there are required core modules for BRFSS, and then there are also some optional modules that states can do, and they can even write their own question. So we're just going to look at some of the modules that states do, and I'm overly excited about this, but I decided we're going to look at California because I'm from California, and my university is in Indiana, so I've only worked with Indiana BRFSS data. So this is my first time working with the California data, and I'm so excited. I wore my California shirt. Can you see that? Let me check if, yeah. So, okay. All right. So, this is a really exciting day for me. Thank you for joining me on this interesting day of my life. All right. So, these are the modules that California opted to do. And this is really important information. But what's missing from this page is the list of questions that aligns with each module. So in order to figure that out, you can search in the codebook. So let's start with this. We'll just look at the first one, alcohol screening and brief intervention, ASBI. So ASBI, you'll see here this is one of the questions from the ASBI module, from this section. All right, so that's good. We could go into the codebook and pull out all of the questions that California completed in the state modules, in the optional modules. But what we also want to know is what questions, what modules did California not complete? Because what we'll want to do is drop those variables from our data file. But we don't have access to that information, and we're definitely not going to go through line by line and just start crossing stuff out, because that is a lot of work. So I have some tricks to get around that. The first thing we have to do is, I shouldn't have taken you away from CDC yet. the first thing we have to do is subset our data file to only California. So what we want to do is filter out only the observations where the individual reported that their state was California. And the value for California is 6. So we'll call this data file California 2017, assignment arrow, filter LLCP 2017, state equals 6. Anytime you want R to go into somewhere and find something where something else is true, you have to put 2 equal signs. If you only put 1 equal sign, it won't work. So that's why I have x_state equals 6. So we just subset our data file. That's California 2017. Let's take a look at it using structure, California 2017. We can see that 9,358 people in California responded to the BRFSS survey in 2017. So we have 9,358 observations. We retained all of our variables. That's good. Let's confirm by looking at glimpse. Glimpse, California 2017. And we see the same thing, right? 9,358 observations, 358 variables. But also, look at all of this missing data. That's too much missing data. And just by glimpsing at our data file, we can get a pretty good idea of which sections California didn't complete. And if I was less experienced with BRFSS, with R, and with BRFSS, I guess, what I would have done in the past is call in each column into the R console or open up the actual data file and inspect everything manually and look for columns where there was at least one person that replied, right? So in order to find all of the variables and all of the columns where there's 100% missing data, I would manually inspect everything, which is definitely not efficient, not a good way to spend your time. So instead, we are going to ask R to give us the column sums, call sums, where there is missing data in our California 2017 data file. Okay, so call sums, there's a capital S here in the middle, is.na means is missing data from our data file. And now it returns back all of the variables and the number of missing values in each. So for example, state has no missing values. This variable called blind has 423 missing values. And what we're looking for are columns that have 100% missing values because we have 9,358 respondents, so we only want to know which columns that nobody replied to at all. So in order to do that, we can return back only the call sums that equal our number of observations, which is 9,358. Now we get our variables returned back to us with true and false. So here, for this variable, nobody replied. For this variable, it's not true that nobody replied, so somebody replied. All right, and I specified the number of rows that we already know we have by looking at the structure and the glimpse. But assuming you're not working with California, you don't need to necessarily specify this number. You can do the number of rows, n row, of your data file. So if you do this, call sums, parentheses is.na, parentheses California 2017, parentheses, equals n row, parentheses the name of your data file. You get the same thing. Okay? So this is really good. This is advanced stuff. We are doing great. But this is also too much work to comb through each variable and find the trues and false. So the way we get around that is by telling R to specify which ones this call sums is.na California equals the number of rows, to specify which ones are true. So the which function returns back only the values of your inside functions that are true. Great, this is more manageable. These are all of the variables that have 100% missing data. This is the variable name. This is the variable name. This is the number, the column number. All right, so this is good. What we're going to do with this which command, this last command that we wrote, is we're going to set this to an object called drop_var, drop variable. All right, so let me bring that function back in. Drop_variable, var, assignment arrow, the which call sums is.na California 2017 equals the number of rows of California 2017. Enter. And now what we can do with this drop_var object, excuse me, is to tell R to, in the same way in the last tutorial that we called columns into our console by specifying, for example, California 2017 bracket, comma, the number of the column or the name of the column. Oh, I spelled Gen Health wrong. Doesn't matter anyway. But the same way that we can specify the number or the name of the column, we can also specify an object that we've set to store a specific set of columns. So drop_var is our set of columns that contain 100% missing data. So we are going to ask R to return only our data frame, to return our data frame only with the variables contained in the drop_var object. Okay, I should have set that command to, you know, just a random letter for an object so that we could look at the structure. All right, so we see we retained all of the observations, so we kept all the rows. And it looks like we have 118 variables that have 100% missing data. All right, let's just confirm that using glimpse. Glimpse A. Look at all that missing data. All right. Yep, we kept the 9,358 observations, 118 variables. So, but this data file is pretty useless to us, isn't it? This is 100% missing data from, yeah, this is just a data file of missing data. So what we can do instead is we can specify, we can tell R to give us everything except, we can tell R to return us every column except those columns, those variables which are contained in this drop_var object. So we do that by putting a minus sign in front of drop_r. So now let's call this California 2017, where we've dropped the variables with missing data. So California 2017 drop_var, assignment arrow, California 2017 bracket comma minus drop_var end bracket. Let's check the structure. All right, so we retained all of our observations, and now we have 240 variables, which is the original 358 minus the 118 contained in the drop_var object. Let's confirm using glimpse. Glimpse California 2017 drop_var. We see the same thing. Ooh. Yeah, we see the same thing. So that is really good. I'm proud of you for making it this far. This is pretty advanced. So we've subset our data file. Now we are going to write a hypothesis based on an urban legend that California girls are unforgettable. So our hypothesis is going to be that California boys, California girls have better health than California boys, which we don't believe, right? Here at R for BRFSS, we believe that California girls and California boys are equally as important, and we appreciate both just as much. But, you know, according to urban legends, California girls are better than California boys. So we're going to play off of this rivalry that I just made up, and for our future analysis, we'll be comparing health outcomes based on sex differences. All right, let's jump back to the CDC website, search for that variable that indicates the respondent's sex. So there are three options: male, female, and refused. Male is the value 1, female is the value 2, and refused is the value 9. So we only want to look at male and female. Now we want to drop everybody who refused to report their sex. So first, let's look at how many male, female, and refused responses we have. We do that by typing count, the name of our data file, California 2017, drop underscore variable, the name of the variable, VARS equals SEX, sex, the name of our variable. So we see that 4,570 males responded, 4,785 females responded, and only 3 people refused to report their sex. So now we want to know who are these 3 people that didn't report their sex. So we do that by calling in the which function, which, where the California 2017 drop variable data file, and the variable by indicating the $, sex equals 9. So it was these 3 people that refused to report their sex. Observation number 32, observation 9040, observation 9159. Now, in the same way that we previously used the which function to assign our drop underscore var object to get rid of those variables, now we want to assign this which function to a new object to drop only the observations that didn't report their sex. So we'll call this object sexr for, refused to report their sex. Assignment arrow, which California 2017 drop variable $, sex equals 9. So now when we're filtering out columns, we can just call the name of the data file and then do bracket, comma, bracket, just do it that way. But if we want to subset rows, we have to use the filter command. So filter, our data file is California 2017 drop underscore variable, where we want to get rid of the rows in the object called sexr. So now we're using this minus sign again to drop these rows stored in the sexr object. And we want to keep all of our columns. And close that bracket and close the parentheses. And we want to set this command to a new data file name or to a new object name. We'll call California 2017 drop variable, only keeping the male and female respondents. Assignment arrow, and then our filter function. Now let's check the structure. California 2017 drop underscore variable mf. All right, and as you remember, we had 9,358 observations. We just dropped those 3 people who didn't respond about their sex. Now we have 9,355 observations, and we keep our 240 variables where at least 1 person responded, right? So these are the, we don't have any variables here where there is 100% missing data. So that is Great. Let's just confirm using Glimpse. California 2017, drop variable MF. And we see the same thing. All right, this is really good. We are making really good progress. If you're catching up, if you're keeping up, just feel really proud of yourself because this is pretty advanced. And this took me a long time to figure out these tips and tricks. So if you're able to understand this and you're feeling comfortable, that is really good news for you. If you're feeling uncomfortable, you can go back and rewatch the video. And I haven't been saying this. I hope you've noticed that I've been putting the code and instructions in the description. So that's there for you to reference. Anyway, our data file name is way too long. I keep mistyping it, and I can hardly remember it. So that was California 2017 drop underscore variable MF. We're going to call this California Girls 17 for California Girls 2017. Perfect. Now we're going to export our data file using the export function from the Rio package. Export California Girls 17 to California Girls 17.csv. Yeah. All right, and let's just confirm. Nope, I don't want that. Let's confirm that that data file successfully exported to our folder. All right, here it is. And it opens much more quickly than the huge LLCP file did. Not that we ever really need to open the CSV file, but it's here for us to import. All right, we'll scroll over. We have all of our variables. You can check on that. We'll scroll all the way down to make sure we have all of our observations. So here we have 9,356 rows, minus the first row is a header, which gives us 9,355 observations. So we successfully subset our data file to the state of California to only respondents who are male and female. So yeah, that is really good news. We did a lot today. Let me just confirm that I didn't forget anything. No, I think we covered it all. All right. Let me just take you back to R for a second. Look at these variable classes right here. Integer, 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 integer. Remember we talked about R, and the Excel file recognizes the responses as numbers, but they're not numbers that we do math on. We really want R to recognize them as factors. So even though we subset our data file, we're really not ready for data analysis yet. We have a lot more cleaning to do, but we'll be working with several different articles, basing our analysis off of several different articles that look at different health outcomes. So we'll be cleaning as we go. Something else we have to do is also set our survey design because BRFSS assigns respondent specific weights to each individual. And this video is getting kind of long, so I'm not going to talk about that now. But anyway, having said all of that, the next time we meet, we're going to start working with some analysis. We will continue to clean our data, and we'll also make sure that we understand and are working with the data file that accounts for the specific weighting scheme of the BRFSS survey. All right, having said all of that, I'm kind of tired. This was a lot to cram into one video, so thank you for sticking through it with me. Give yourself a break now, and yeah, I hope you join me for the next video because we finally have our data file ready. We can finally start doing some analysis. So this is where it gets really good, guys. I hope you join me next time. I'm just closing out everything. All right, thank you so much. I'll see you next time. Bye.